So we're now going to give an example of how to use L'Hopital's rule. And the example we're going to consider is the limit as x tends towards infinity of x squared divided by e to the x. So this expression here is on the form infinity divided by infinity, since x squared goes to infinity and since e to the x goes to infinity. Now, once you have a limit that's on the form infinity divided by infinity or 0 divided by 0, you're allowed to apply L'Hopital's rule. And this I just indicate as follows. And now what I can do is I can replace the guy on top and the guy below by their respective derivatives. So here, L'Hopital tells me that the limit is now equal to, if I take the derivative of x squared, and if I take the derivative of e to the x. And notice that since the derivative of e to the x is e to the x, nothing changes down here, but up here, the power was improved. Okay, so I went from x squared to x. Now this limit here, of course, is also on the form infinity divided by infinity. So I can use L'Hopital again. And by using L'Hopital again, what do I get? Well, now my 2x has turned into a 2, and my e to the x is still an e to the x. And what is this limit? Well, 2 is just a constant, and now I have e to the x here, which I know goes to infinity. So the limit here goes to 0. We are done. Now, of course, if I have my table of signs, I know my e to the x is stronger than my x squareds and my x to the third and whatever. But if I forget my table of growth, then L'Hopital is an excellent way of checking this or recalling this, or even if you want, proving this. And notice if I had x to the third, I would still get 0, except I would have to do one more step. If I had x to the fourth, one more step again, and in this way I can prove using induction that e to the x kills any x to the n. And that's it.